All right, so good morning, everyone, or good afternoon, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And we are particularly excited this October because we are spending the entire month of October celebrating space with engineers, roboticists, astronauts, more amazing people pushing the boundaries of our exploration of the universe around us. So thank you guys so much for being a part of that. Right now, we've got 3 classes joining us from across North America, so I'm going to give them a chance to say hi before we dive in. We've got Mr. Pletz, grade 5s in Winkler in Manitoba. Hi, guys. Hey, so nice to have a Manitoba class, and I love it. We've got Julie's class at the Ontario Science Centre, grade 12s in Toronto. Hi, guys.
Hi.
Hey, taking their lunch hour to spend it with us, and I appreciate it. And then last but not least, we've got Miss Russett's grade 5, 6s in Arnprior, Ontario. Hey guys, how you doing? We've got all the enthusiasm today. Awesome. All right. Of course, the reason you guys are all here today is for our speakers. So we are joined live in Pasadena, California by Dr. Marc Rayman. So he is a physicist and engineer at NASA's Jet Propulsion Laboratory, one of the most storied and amazing research facilities in the entire world, as I said, pushing the boundaries of space exploration. So he said before we got all started here that he's wanted to do this since he was 4 years old, and that will shine through in the whole presentation. We're going to dive in with his amazing passion for what he does and how much he loves his job in a second. But as an engineer, he gets to work on a huge variety of projects. He's currently the chief engineer and mission director for Dawn, which is orbiting a dwarf planet at the edge of our solar system. So we're going to learn a little bit more about that and about Marc's work generally. Without further ado, thank you so much for joining us, Dr. Rayman, and take it away.
Can you hear me okay?
Yeah, you're perfect.
Well, thank you very much. And hi, everybody. Thanks for joining me today. As you just heard from Jesse, I'm doing what I've wanted to do my whole life. I got interested in space when I was 4 years old. And when I was in the 4th grade, I decided I wanted to get a doctorate in physics, which is a kind of advanced degree in science. And I wanted to work for NASA. It was a few more years till I did, but I'm doing what I wanted to do my whole life. And every day, I just think this is so cool. I feel so lucky. I feel like a big kid. I'm just getting to have great fun. And so I want to show you some of the things I've been working on recently and hope you think it's interesting too. So I'm going to share my screen here, and Jesse will confirm for me that in a second that
wants to work.
Everything look okay?
No, so I still have just you up right now.
Okay, well, I clicked the share screen.
It worked in practice.
It actually says screen sharing has failed to start. Please try again later.
Oh, well, why don't you dive through with a little bit about what you get to do, and then we'll try in a few minutes and see if we can get the images up then.
Okay, so I've been working on this mission that, as Jesse told you, is called Dawn. And one of the things that I think is so cool about it is we've gotten to explore alien worlds. The spacecraft went to the main asteroid belt, which is between Mars and Jupiter. I think many people think of asteroids as like chunks of rock, maybe the size of a building or the size of a mountain, right? That's how they're often depicted in movies. But these places are really big. And to me, they're not just chunks of rock, they're whole alien worlds. And what could be cooler than sending a spacecraft to a distant world that we can only view faintly through a telescope? And that's what I think is so neat about what I've gotten to do. And so let me try again here to share my screen.
You're perfect. It worked.
Okay, good. So you can see my opening slide there?
Yeah.
Okay, so the main spacecraft here across the center is called Dawn. And you see Ceres over here. Can you see my cursor?
Yes, we can.
Okay, so Ceres is where the spacecraft is right now, but we first visited another alien world called Vesta. And just for fun, because I love this so much, I put in another spacecraft that I worked on with the cool name Deep Space One, which got the United States' first close-up pictures of the nucleus of a comet. But let me go on with a little bit more about Dawn. And so here's just a picture of the night sky. When you look up at the night sky, you see lots of stars, and maybe you know that some of them are planets or something else, but you really can't see much. And if you just look at one faint dot in the center, you can't really tell anything about it. But when we use the powerful Hubble Space Telescope, we can zoom in and see it's not just a point of light, it's kind of a fuzzy little blob. And when we send the Dawn spacecraft there, we can turn it into a true alien world. And to me, that is just so cool, to send a spacecraft to a distant point of light in the night sky and then see all this incredible detail. And since Jesse mentioned snow at the beginning, I'll mention that we nicknamed this the Snowman, a group of 3 craters. And of course, we saw a lot of other things on this alien world. And I'm just going to show you a movie of what it would look like if you were lucky enough to be there. And so you see there are, of course, a lot of craters all over the place. But also, I want to draw your attention here as we come down to near the equator. You can see what turn out to be a lot of canyons. And in fact, many of these are larger than the Grand Canyon in the United States. Excuse me, there are more than 90 of these. And they're left over from an impact with another asteroid that occurred 1 billion years ago. And when that impact happened, that is a big object hit Vesta near the South Pole, it made a big crater here, 300 miles, 500 kilometers in diameter. And we're now seeing this crater, this is part of the crater wall right here, with a mountain in the center. This mountain is 110 miles across and rises to 2.5 times the height of Mount Everest. So the planet you live on doesn't have anything that can compare with this. And that again is part of what I think is so cool about this. We got to go to this alien world and discover this huge crater with a mountain more than twice the height of Mount Everest, the tallest mountain on Earth. What could be cooler than that? Well, I'll show you something that I think actually is cooler than that. And that is where the spacecraft is right now, at a dwarf planet called Ceres. And here it is in views from the Dawn spacecraft. And again, you can see it has a lot of craters. It also has a lot of other strange features, especially including these bright places like this. And here's a close-up view of that crater. Now, this crater is more than 50 miles across. Think of that. So the whole city that you live in and all the surrounding areas would just fit maybe in this bright area at the center. When we got these pictures, we wondered, what could this bright area be? And of course, we wanted to get closer and get even better views. And sure enough, we did. And it kind of looks like snow. But what we now know is that Ceres, this alien world, has underground salt water. And sometimes that water makes its way to the surface, like through these canyons here that you can see, big cracks in the ground. The water makes its way to the ground, excuse me, makes its way to the surface, and then essentially evaporates. For the older students, we could say it sublimates, but you could say it evaporates and leaves behind the salt that was dissolved in it. So what you're seeing here are giant salt flats, many, many miles across. And so they reflect more light than the normal ground does. And now here we're taking a look at the same crater from the side. And I want to zoom in a little bit because we got our spacecraft a lot closer. And now I want to show you some, I think, cool close-up pictures. So the first is going to be over here on the crater wall. And just look at this crater wall with these big rocks sticking out of it. I just think that's really cool to be able to get close enough to this crater to see that. And we can look at this strange, again, these salt deposits here, and look at this weird landscape. I mean, this looks like a huge square, and this is about a mile around. It's a huge place, but you see that it's cut across by this deep canyon, and you can sort of see here it's shaped like a V, and we think this is how the water got up to the ground, flowed across the surface, evaporated, and then left behind these salts. We can get in still closer, and now I'm going to flip you around to the other side and take a look at this mountain here. And here again, this strange scenery. And you can see this stuff looks like it flowed down here through cracks because it was at one time possibly in water. And we can take another look here. It's still another area. And it's just, I think it's really amazing to look at how sharp the border is between the bright area and the dark area. It's a very strange alien sight, unlike anything you would see on Earth. And then we can fly up still higher and take another look and just remind ourselves of how weird this place is with these craters that look like lots of things you've seen in pictures of other planets, but with these brilliantly glowing, features here that almost look like they're emitting light, although of course they're not. They're just reflecting it. And I want to show you another picture. Here, again, lots of craters and things, but look on the horizon, there's a mountain here. And this is the tallest mountain on Ceres. It stands about as tall as most of the tallest mountains in the continental United States and in Canada. And it turns out to be a volcano, an extinct volcano. And you can see another view of it here. It just juts up from the landscape. Now on Earth, volcanoes are made from magma and lava. I'm sure you've heard of lava. On Earth, it's very hot, right? But Ceres, it's farther from the sun. It's much colder there. And so instead of the lava being hot like we think of here on Earth, it's actually cold. It's made of water and mud and rock and ice. And in fact, it has a lot of the same properties on Ceres that lava does here on Earth, but everything is much colder. And so I just think that's a really cool view. And I want to show you one more picture from Ceres that I really like. This is the wall of a crater, and then here's the floor of the crater. And if you look, you can see the trail of maybe a rock that tumbled down the crater wall. And if you look closely, you can actually see the rock at the bottom. And you can see that in other places as well. Here's another place where a rock bounced and tumbled down the crater wall, and there's the rock at the bottom. And in fact, there are a lot of rocks here we can see on trails. Here's one that crossed the other trails. So we got so close to this alien world that we could see individual rocks on the ground. And I also think it's neat because up here you can see some on the crater wall that have slid partway down, but haven't yet fallen the rest of the way, although surely they will at some point. Now, our ability to send a spacecraft to this alien world, or in fact, these two alien worlds, Vesta and Ceres, and to go into orbit around them and study them, turns out a mission like that would be not just difficult, but impossible. Impossible if we didn't use ion propulsion, which I first heard of in Star Wars. And maybe you recognize here the Star Wars TIE fighter, TIE. Well, in Star Wars, the TIE fighter stands for Twin Ion Engine, because this was the most futuristic, coolest, advanced technology they could think of. And to me, one of the fun things, one of the many fun things about getting to work for NASA is I get to turn that science fiction into science fact. And so here's an artist's concept of Dawn using its ion engine, the real thing, as it flew into orbit around dwarf planet Ceres not too long ago. And I think this is so cool to be able to get to use something I heard of in science fiction, but to turn it into the real thing, not just for a movie, but for a real space flight. And here's an ion engine operating here at the Jet Propulsion Laboratory in Pasadena, California, where I work. And you can see it really does produce this cool blue glow like in science fiction movies. And the reason for that is not because we got the idea from science fiction, but rather because they got the idea from the real thing, which is what we do. And here's an artist's concept of the spacecraft with one of its 3 ion engines. We actually have 3. And here it is firing up the ion engine. And this is very much what the spacecraft looked like as it traveled through the solar system from Earth, past Mars. We went far beyond Mars, excuse me, to Vesta, and then on to Ceres. And that's what the spacecraft looks like. And here's the real spacecraft. When it was being built, we wear these, what we call bunny suits. That is these white protective outfits to keep any little particles of dust or hair or skin from getting into the spacecraft. And this is the actual spacecraft. Here, these big solar wings are folded up because you can't fit a big spacecraft inside the little nose cone of a rocket. So we fold it up. This is the main antenna. This is one of the ion engines. And this is my friend Tom. And when we get the spacecraft in space, these solar wings open up. And I'll show you an artist's concept of that in just a moment. But here's what it looks like when these solar array wings are opened up. This is really a huge spacecraft. In fact, from one wingtip to the other is 65 feet or 20 meters. That's the distance from a pitcher's mound to home plate in a professional baseball field. This is a big spacecraft. And when we launched it, we did it from Florida, as we do most of the launches, from Cape Canaveral. And we had a really beautiful launch and got the spacecraft up into space. And then this is a different spacecraft that I worked on, but one that's very similar. And so you can see it extends those solar arrays and then points them at the sun. And then the sunlight produces electrical power to operate all of the systems. And here you can see it leaving the Earth and the Moon behind as it fires up its ion engine. And with the electricity from the solar panels, we can run the ion engine, the radio, the computer, the cameras, and everything else in order to make this spacecraft do what we want. And now, just to finish off, this is the orbit that the spacecraft is in right now. There it is, circling, or not circling, but flying around Ceres. And once every 27 hours, that's about once a day, it goes down to a really low altitude like that. And that's what allowed us to get those close-up pictures. And the spacecraft actually recently just completed its mission, but it's going to stay in this orbit for many, many decades, probably even for centuries. So when you grow up and have children, and they grow up and have children, and they grow up and have children, and even they grow up and have children, for probably hundreds of years into the future, the Dawn spacecraft will be orbiting dwarf planet Ceres, and you got to hear about it today.
Very cool. Thank you so much, Dr. Rayman. That was amazing. It's so nice to be able to take something that's so far away and so outside of the realm of everyday experience and turn it into a place that we can actually see and conceivably even visit one day in the distant future. But yeah, so that was fantastic. We're going to dive in with questions. I know Mr. Plett's class has to go in about 10 minutes, so we're going to take some questions from them first. We also have Miss Annie Tully's class join us, so I'm going to make sure they have a chance to introduce themselves in a minute. And we have quite a few groups watching on YouTube. So if you guys are watching on YouTube and want to type in a question, you can do so, and then I will share it directly with Dr. Rayman. So please go right ahead with that. But yes, let's start with Mr. Plett's class. If you guys want to kick us off with a question, come on up.
Can you go into the surface of any planet?
Did you say, can you go into the surface of any planet?
Yeah.
Yeah. Well, any planet that has a surface. Now, not all planets do. Some of them, maybe we don't know for sure, but maybe are mostly just gas. But any planet that has a surface, I mean, basically, if you have a shovel, you can go into it. It may be a lot of hard work, but we certainly are trying to do that. When Apollo astronauts went to the moon, they used a drill to drill down into the ground. And even right now, we have a spacecraft on Mars called InSight, which has a device that's trying to dig down to get about 15 feet, or 10 to 15 feet, several meters underground. And I think that would really be fascinating to do on other planets as well.
Very cool. All right.
Did that answer your question?
Let's see. Is that good, guys? Yeah.
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 Perfect. And then if you have a second question, come on up.
Annika, you want to ask yours here?
Wait, I thought I was-
Okay. So here, Cecilia, you can ask this one.
How do you take pictures of something so big?
Did you say, how do we take pictures of something so big?
Yeah.
Well, that's a great question. We start out when, if this is the place that we're going and here's the spacecraft, when we're far away, we start taking pictures when it's still small. Just like, I mean, you could easily take a picture of the moon, right? Because it's big, but it's far away. And then as we get closer and closer and closer and closer, we get pictures of smaller and smaller and smaller parts of the place, but more and more detail. So it would just be like, if you're looking at a friend of yours from far away, you could see actually a whole crowd of people, right? You could see a lot. That's like seeing a big place. But then when you get closer and closer and closer, you stop seeing all the people that are sort of on the sides, and then you focus in just on that one little narrow place. Does that make sense?
Yeah, that was great. All right, let's go to Julie's class. If you guys have a question, come on up.
Yep, we have a question. I think Vignan's gonna ask. I think you just come right. Where am I?
You're perfect. Where you're standing is excellent. There you go.
Okay. There you go, Vignan.
Hi, what do you study in post-secondary?
So what's your educational background, Mark?
Yeah. Okay. So after high school, I went to Princeton University in New Jersey, and I majored in physics, which is a branch of science. You probably know that, but maybe for some of the others, it's one of the branches of science. But I'll tell you, as much as I love physics, and I took tons of physics and math courses, and I loved every one of them, I took a lot of other things too. I liked learning French, history, archaeology was actually one of my favorite classes, psychology, all kinds of other things. So one of the things I promised myself when I went to college was every semester I would take a class in a different department, a new department that I hadn't previously studied, because I think there are just a lot of great things to learn about. But again, I concentrated on physics, with most of it being in astrophysics and cosmology, which is the study of the whole universe. Then after I got my, what we call bachelor's degree, I went to the University of Colorado in Boulder for more physics and math, specializing in nuclear physics. And then after I finished that, I continued working at the University of Colorado in Boulder, along with an organization called the Joint Institute for Laboratory Astrophysics. And I worked on atomic physics and lasers and a field called special relativity, and got my doctorate there and had a great time. I just love learning new things.
So out of curiosity, this is like that was a great step-by-step story. How many years of schooling is this?
This was a lot. So I finished school when I was at the advanced age of 29. Just imagine. And I had, of course, some summers off, but from this time I started school and, at the age of 4, I went essentially continuously until I was 29 years old. And that was a long time, but I got to learn a lot of cool things, and I get to use them every single day at work.
That's very cool. And I did love that one of the students' mouth actually dropped open when you said 29. So I appreciate it. And I love that you mentioned that you took these other courses too. So this is something that we're increasingly seeing, and we've talked about with a lot of the other NASA people we work with, is that if you want to work for such an amazing institution, I mean, if you want to be a scientist, that's fantastic. But if you want to be a business person or an accountant or an artist or any number of jobs, there are roles for you at places like this to share that.
Sure, absolutely. In fact, at the Jet Propulsion Laboratory here where I work, we're responsible for exploring the solar system. So we've had spacecraft from the inner solar system to the outer solar system, but it takes a lot more than scientists and engineers to do that. We need business people because we buy a lot of products. We need lawyers to make sure we do it legally. We have doctors and nurses here. We have our own police department, fire department. We have people who maintain our grounds here, gardeners and painters and plumbers. I mean, we have the entire field. It's like a little city here, and that applies in a lot of other places as well. So if you're thrilled about space, you don't, although I think science and engineering are the best way to get into it, there are other ways as well that you can have very rewarding careers, because every one of these people gets to contribute to the exploration of space.
Very cool. All right. Miss Annie Tully's class joined us, grade 5s in Queensbury, New York. So I know you guys are on lunch, so you don't have your video working, but if you want to ask a question, your mic's demuted.
Okay, go ahead.
Hey.
How is the volcano in space able to have water and be cold?
Yeah.
Yeah, that's a good question. Well, so the volcano, first of all, it's set on space, which is fine, but it's actually on this alien world Ceres where everything is colder. So compared to the rest of the areas around there, the water is actually warm. It's just warmer than the rest of the ground because it's heated from inside Ceres. Just like in the core of Earth, it's hot. Maybe you know that's why lava is hot on Earth, because it comes up from underground, heated by the heat inside our planet. Well, on Ceres, that water is warmed up by the interior of Ceres, and that's enough to push it up to the ground where it erupts. And I mean, you could imagine, just think of a fountain here on Earth, right? Water can squirt up and come down. Well, I mean, the same thing can happen on Ceres, but in that water is also a lot of, again, ice, some particles of ice and rock and salt. And so it's sort of like mud coming up on the ground. And then gradually over time, it cools off. And so it leaves that volcanic dome. Did that answer your question?
Yeah, that was great. You're a good answer. Don't worry. You're nailing it. All right, Miss Russett's class, if you guys want to come up and ask one, go for it, guys.
Hey, so if you brought up like trees for oxygen, and because you have water up there, do you think it would be inhabitable?
Terraforming.
Yeah, that's a cool idea. On Ceres, there'd be a couple of problems with that. One is, first of all, it's pretty cold there. And so I'm not sure the trees that we have on Earth would grow very well there. But even if they did, Ceres is much smaller than Earth. And so its gravity is not as strong. And so if the tree produced oxygen, it might not stay, excuse me, it wouldn't stay at Ceres. Ceres' gravity isn't strong enough to hold it. So like the atmosphere here that we breathe, the oxygen, is held to Earth by Earth's gravity, the same thing that holds you and me down. That's why when you throw something up in the air, it comes back down because of gravity. And that's what holds the air to Earth also. But Ceres doesn't have as much gravity. And so the air, the oxygen that the trees produce would escape out into space. And so we wouldn't have anything left to breathe. So I think if we go to Ceres, or not if, when, we're going to have to wear spacesuits or build buildings to keep the oxygen enclosed.
Yeah, it's a really great question. I'm really happy we got on something with trying to make another planet inhabitable. So with a moon, in fact, the students might know, they might not know, but a Chinese spacecraft landed on the other side of the moon and it didn't plant a plant, but it had a plant grow on it. So it was the first, biological life other than people to be on another world. So that's a very exciting moment for space exploration.
It is.
All right. We've got Miss King's class joining us online on YouTube, grade 6s in Cambridge, Ontario. And so Joe and Finn in their class wanted to ask how long it took to build Dawn.
We started designing Dawn. Well, let's see, I guess the total time it took from the time we started designing it, that is figuring out where each device is going to go on the spacecraft, what's the overall spacecraft going to look like, how are we going to fit this piece to this piece, all that. From the time we started designing it until the time we finished building it was about a little more than 3 years. And then once we finished building it, we had to test it thoroughly because we sent this spacecraft, think of this, more than 1 million times farther from Earth than astronauts on the International Space Station. 1 million times farther away than astronauts. So we couldn't take a chance that it might break or that there would be a problem because we wouldn't be able to fix it. And so after the 3 years of building it, we spent another almost 2 years testing it, putting it through its paces, making sure it would work reliably. And only then were we comfortable to put it on top of a rocket and send it well over 1,000 times farther away than the moon.
Wow, very cool. All right, let's go back to Julie's class. If you guys want to have another question, come on up.
Oh, yeah. How does the ion engine work? And like how can the spacecraft stay in orbit for like decades and decades?
Yeah.
Okay, so that's 2 questions. The first is, how does the ion engine work? Let me first just give you a brief summary of how a regular rocket engine works. You take a gas and you heat it up, or you put it under pressure and you push it out of a rocket nozzle. And the action of the gas going out of the nozzle causes a reaction that pushes the spacecraft in the other direction. And if you've ever taken a balloon and just let go of the open end of the balloon, the gas rushing out of the balloon pushes the balloon in the other direction. So the ion engine works on the same principle, but we don't heat the gas up, we don't put it under pressure. Instead, we give it a little electric charge. Now, for some of you, maybe I'll just remind you, not everybody will follow this part, but hang on for a second. Even if you don't, I'll get back to something that you get. The atoms consist of a positively charged nucleus consisting of protons and neutrons, surrounded by a cloud of electrons, and we remove one of those electrons. Then the atom is called an ion. And what really, that's why we call it an ion engine. And what the ion means is it's electrically charged. And if it's electrically charged, it can feel the effect of a voltage. So we take 2 metal plates and put them very close together. They're separated by only about 10 times the thickness of your hair, or maybe 20 times the thickness of my hair. And we put 1,300 volts between them. And that allows us to electrically accelerate these ions. So if this is the ion engine here, and the spacecraft is over, so here's the spacecraft, here's the ion engine connected to it, here are the 2 metal grids, we put a big voltage on them, and we shoot these ions out of the engine at speeds up to 90,000 miles per hour. And the action of these ions going this way causes a reaction that pushes the spacecraft this way. And it's incredibly efficient. This is like 10 times the efficiency of your car. So this would be like being able to go 10 times farther without refueling your car. And that's what allows us to undertake this ambitious mission, to go to one alien world, go into orbit around it, maneuver there, break out of it, then go to another alien world, go into orbit around it, and maneuver around it. And your second question was, or I hope that answers your first question. I'll just count on you to speak up if it didn't. Your second question was, how can the spacecraft stay in orbit around Ceres for so long? And the answer is, excuse me, objects stay in orbit without propulsion, just like Earth has been in orbit around the sun for more than 4 billion years, right? The moon stays in orbit around the Earth. It's been more than 4 billion years also. They don't have propulsion. In space, there's no air resistance. There's no friction. You know, on the ground, I mean, on Earth, a car will roll to a stop because of the friction between its wheels and the ground and because of air resistance. And that's why we have to keep our foot on the pedal when we drive a car, or a plane has to keep pushing through the air because the air slows it down. But in space, there's nothing to slow it down, nothing to stop. So an object just keeps going until something interferes with it. And so once we got it into orbit around Ceres, where Ceres gravity is holding onto it, just like the sun's gravity holds onto Earth and Earth's gravity holds onto the moon, it just keeps going until something else interferes, which maybe will be some of you in 20 or 30 or 40 years flying your own spacecraft out to Ceres and grabbing a hold of our spacecraft. But until then, it's just going to stay in orbit.
Very cool. Not only were those great answers, but you are the only person probably ever to sneak in a balding joke into an ion propulsion, engine answer. So I appreciate that immensely. Thank you. A nice mug, by the way. I want the classes to take a look at that. That's what you aspire to in your mugs in life. All right. We're going to take a couple more questions from groups online, and then we're going to go back to Miss Russett's class to finish us off. But yeah, Miss King's class, Evan wanted to know if there was any one thing that sparked your interest in this field, Dr. Raymond.
If there's any one thing that sparked my interest
in the field, like what got you into this? You started when you're 4. Was there something that really drove you?
There was. So remember, I was just a 4-year-old kid, but I was really scared of witches, like that fly on broomsticks. They used to terrify me. And I grew up in Toledo, Ohio, and every day on TV, there was a friendly witch who came on, and I think she was supposed to be funny, but it terrified me every single day that I saw this TV show. Well, I was outside one evening in Toledo with my parents and saw a meteor, a shooting star, a thing streaking through the sky. And being ever the logical youngster, I thought, okay, that's a witch flying on her broomstick through the night sky. I mean, what else could it possibly be? And so, like every other time I saw a witch, like in The Wizard of Oz, if you've ever seen that, or other movies, it just terrified me. But my parents said, no, it's not a witch, it's a shooting star. I didn't understand what that was. But what they said is, it's something from space burning up in the atmosphere. And that's what got me hooked on space. I just thought, wow, yeah, this is so cool. It's not a witch. This isn't fantasy. This isn't fiction. This is the real world. There's a piece of material from outer space coming down into our atmosphere, burning up. I mean, I didn't have all of those words to think about it like that when I was 4, but it just got me fascinated, and I've been a space enthusiast ever since.
Outstanding. What a great answer. Also, the only witch-based answer we've ever had in the history of Exploring by the Seat of Your Pants. So you're 2 for 2 now.
Okay. Going for 3. We'll see.
Yeah. Before we go to Ms. Russett's class, the only other question from the group online, what's the deal with the Ceres cereal box? Like, is it a real thing? Is it a novelty thing? Can we get it? What's going on?
Okay. So, yeah, what they're referring to is this box of Ceres O's. And the deal is, so I give a lot of public presentations. I like talking to students and everybody who's interested in space or wants to learn about it. And so I often draw the connection that Ceres comes from the same word as cereal. They both come from Latin. Ceres was the Roman goddess. The Romans believed in many gods and goddesses. Ceres was the goddess of agriculture and grain. And so cereal, the word that we use, comes from the same thing. So I actually made a YouTube video. You can look for it. It's if you just do a Google search, I think it's called Breakfast at Dawn. Get it? My mission is called Dawn, Breakfast at Dawn. And I talk about the connection just to help people remember the name. And so somebody at JPL made this for me. It actually isn't a real kind of cereal, but we made it for the video. And in fact, if you watch the video, you'll get to see that this box of cereal even comes with a little prize, which in fact is the Dawn spacecraft. So look for that video, NASA Breakfast at Dawn, and you can see that. So, and this is the box of cereal we used in the video. So I just keep it as a fun souvenir.
Perfect. I will share that with the classes when we're done too. That's amazing. All right, Ms. Russett's class, end us off. Come on up for one last question, and thank you guys so much. This has been great.
And have any other speakers mentioned cereal in their presentations?
No, it's disappointing. So 3 for 3. You're right.
Okay.
Perfect. Come on up, guys.
Have you ever come in contact with a planet that could have life form?
That's an interesting question. And yes, I absolutely have come in contact with a planet that could have life forms. In fact, I live on one, and so do you. And Earth is, in the sense of the overall universe, Earth is just another planet. We know already, we've discovered thousands of planets. We know there must be millions upon millions upon millions of planets. We haven't detected life on any other planets. but we've detected the conditions that we think might be right for life to develop. But since we've only been able to study life on Earth, we don't know yet enough about what does it really take? What combination of chemicals and physical processes and environments like here on Earth did life get started deep in the bottom of the ocean? Did it get started in a pond? Did it get started in other environments? What exact chemicals are needed? How much sunlight? Did lightning maybe play a role in causing some chemical reactions? So scientists are working hard to understand what it took for life to develop here on Earth. And only when we fully understand that will we be able to predict whether or not life might be on other planets, or of course, if we find life. But even Ceres has many of the conditions that we believe are necessary for life. It's got water, it's got internal heat, it has a wide range of chemicals that we believe are related to the chemicals that gave rise to life here on Earth. Mars may have had those conditions at one point. One of the moons of Jupiter, called Europa, maybe did. One of the moons of Saturn, called Enceladus. So we're looking at these different places and looking throughout the universe to try to find life elsewhere and to study it more thoroughly here on Earth to understand what the scientific origin of life is. But we don't have all the answers yet. One of the things that I think is so cool about science is it gradually makes progress, and eventually we'll get it figured out. Maybe you'll contribute to that sometime too.
Outstanding. Dr. Rayman, before we wrap up, is there any last place you want to guide kids to, other than your amazing serial video, where they can learn more about the work you guys are doing, JPL, space exploration in general?
There is actually. So NASA has a website called Spaceplace, all one word, spaceplace.nasa.gov, which has a lot of fun and interesting educational activities, all kinds of cool things that you can find there. And in some places now, I used to work on this website myself. I don't so much anymore. But if you look around, there are some places you'll find a character called Dr. Mark, who has a big nose and a high forehead, just like I do. And maybe when you see him, you'll remember my big nose and forehead.
Outstanding. So I'll pass that along to our classes as well. Thank you so much, Dr. Rayman. Well, at the end of every session, what we do, I'm going to just demute the class's microphone. So Julie's class, Miss Russett's class, if you guys could just join me in saying a huge thank you. You're both demuted. Go for it.
Thank you.
You're welcome.
Awesome. Appreciate you being here so much for our classes. Do join in again soon. An entire month dedicated to space. We've got a lot more really cool stuff coming down the line. Dr. Rayman, that was fantastic. Thanks so much.
It was my pleasure. I enjoyed talking to all of you.